are 4 components to a perfectly level edge. There's the accuracy of the sharpener, there's the accuracy of the edge checker, there's the accuracy of the grinding wheel that's putting the shape into the blade, and finally, the hardest one to control that we cannot control at Sparx is the accuracy of the skate steel. We hear this all the time from even our pro NHL equipment managers, that there are certain skate steels that when you sharpen them on a completely aligned machine, you get a skate blade with edges that are not level. Beam takes into account all of those factors. With the introduction of Beam, it makes sense that we talk about the evolution of the edge checker and where edge checking has come from and to where we're taking it with Beam. When we began the company 10 years ago, this was the standard for edge checking. It's a reference plate that you attach to the skate blade, and then you put a tilt bar on the edges. This tilt bar lines up against a grid that the user is supposed to read and interpret. Over the years, the edge checker has evolved. Some edge checkers were made purposely to be less expensive, and so the manufacturing methods were different than the original edge checker when we started the company. And so they moved towards things like stickers instead of the machined in lines. They moved towards adhered reference planes instead of machined in reference planes. But the edge checker really didn't evolve much until Sparx several years ago decided to improve the machining of the edge checker to make it more accurate, the storage of the tilt bar so that the tilt bar wouldn't get damaged as it was used on the skate blade, which is very sharp and very hard. And so on the previous versions of edge checkers, the tilt bars would get damaged, which would alter the reading. And then one of the things that we discovered or understood was that with an edge checker, no one knew how to interpret the tip of the bar and where it landed against the reference. And so we created the green zone on the side of the edge checker, which allowed us to tell our customers, if your edge checker bar lands in the green zone, the skate is okay to skate on. So if the tilt bar landed in the green zone, we advised our customers skate on that skate. But what happens if the tilt bar falls outside the green zone? There's really no way, because there's too many factors involved through a manual edge checker, an analog edge checker, to give a recommendation to the customer. The reason is, to go from an edge checker reading to a sharpener adjustment, you have to know many factors. Over the years, the evolution of edge checkers prior to about 4 years ago really hadn't evolved all that much. When we began looking at the edge checker, we had a few things that we wanted to improve. One was the accuracy. You can see here in this prototype, one of the ways to improve the accuracy of the edge checker is to make the edge checker longer and amplify the reading. The challenge with amplifying the reading is you still don't know what to do with the reading. And so we pulled back from making the edge checker larger and amplifying the reading to focusing on the same length, which gives you accuracy down to 1/1000th of an inch, or 1/3 the thickness of a sheet of paper. And what we focused on was some of the key problems with edge checkers prior to this. One of the problems was the tilt bars would get damaged by the hard and sharp edges of the skate blade. So we focused on improving the durability of the tilt bar. We provided a storage location for the tilt bar. And we also provided an indication to the user, once they're doing their edge checking, that if the tilt bar lands in the green zone, representing less than 0.02 of an inch edge-to-edge variation, that they can skate on that skate blade. But the problem came where users would find sharpened skates where the tilt bar fell outside the green zone. This is the subject of many posts on social media. My skates are falling outside the green zone. How do I fix my sharpener? The challenge with the traditional analog edge checker is the number of variables that you need to understand to convert an analog reading of an edge checker to an adjustment on the sharpener is enormous. For example, first, the analog edge checking reading is very subjective. I don't have a numerical reading for the amount that these edges are off. Second, to make an adjustment on a sharpener in order to fix this reading, I would need to know the following things. I would need to know the direction that the skate is facing in the sharpener. I would need to know the thickness of the skate blade. I would need to know the radius of hollow that I sharpen this skate with. I would also need to understand the relationship between the adjustments on the sharpener and the machine's movement. And lastly, I need to know which direction I did my edge checker reading. Did I do my edge checking reading with the toe of the skate facing me or the heel of the skate facing me? If I understand all of those variables and I had a numerical representation of these edges, I could then provide that recommendation for how to adjust the sharpener. That's where Beam comes into play. What Beam does is it uses a precision laser sensor pair, has an integrated tilt bar, and immediately gives you stoplight indication of your edges without the use of the Sparx app. So right out of the gate, I know these edges are green, they're within 0.02 of an inch, and I can skate on them. Similar to the green zone on the original Sparx analog edge checker. The magic comes into play when you integrate with the Sparx app. So what the Sparx app does is the Sparx app converts this tilt measurement via the laser and the sensor into a numerical value of edge-to-edge height variation, and it takes in all of that information, radius of hollow, blade thickness, skate direction in the machine, skate direction on the edge checker. It converts that to a simple recommendation of the amount of clicks I need to adjust my sharpener and the amount of passes I need to get to a clean, perfectly level edge. Beam takes all of that information and converts it into a simple, easy to understand number of clicks, number of cycles of the machine to get to a perfectly level edge. The beauty of Beam is Beam can provide that recommendation for every generation of Sparx sharpeners from generation 1, generation 2, generation 3, and forward. What this does is it allows every owner of a Sparx sharpener to upgrade their machine, upgrade to an integrated sharpening experience for their homes, to take edge checker readings and instantly convert them into actionable instructions to make your sharpener produce perfectly level edges. For more information about Beam, either download the Sparx app or visit sparxhockey.com.